Okay, for the last part of A5, we're going to solve radical equations. So first we want to isolate the square root, cube root, or fractional exponent if possible. Square or cube both sides or get rid of the fractional exponent by using the reciprocal. Then solve for x and then check for extraneous solutions. So in number 19, first we want to add 4 to both sides. So we get square root of x minus 10 equals 4. And then to get rid of the square root, we can square both sides. So we get x minus 10 equals 16. Add 10 to both sides. So x equals 26. But before we say that this is our final answer, we want to check that it actually works. So we want to plug in 26, or x equals 26 into the original equation. So that'll be 26, square root of 26 minus 10 minus 4 equals 0. Square root of 4 minus 4 equals 0. Oh, oops, sorry. Square root of 16. So we get 4 minus 4 equals 0, which is correct. So that means 26 is the solution. This next one, we have a cube root. And again, we want to isolate the cube root. So we're going to subtract 3 on both sides. So we have cube root of 2x plus 5 equals negative 3. Then to get rid of the cube root, we're going to cube both sides. So we get 2x plus 5 equals negative 27. And then to solve for x, we're going to subtract 5. So 2x equals negative 32. Divide by 2. And we get x equals negative 16. Then we'll want to check. So we want to plug in negative 16 in for x. So I have cube root of 2 times negative 16 plus 5 plus 3 equals 0. So cube root of negative 32 plus 5 plus 3 equals 0. Cube root of negative 27 plus 3 equals 0. And the cube root of negative 27 is negative 3. So we get negative 3 plus 3 equals 0, which is true. So that means negative 16 is the solution. Next, we have x plus the square root of 31 minus 9x equals 5. So we want to isolate the radicals, so we're going to subtract x on both sides. So we have square root of 31 minus 9x equals 5 minus x. You could also write it as negative x plus 5 if you want. Okay, so we have a square root, and to get rid of it, we're going to square both sides. So we get 31 minus 9x equals 25 minus 10x plus x squared. So that's using the perfect square trinomial. And now we want to move all of the x's to one side. So I'm going to add 9x and subtract 31. So we get x squared minus x minus 6 equals 0. And then to solve from here, we want to factor. So on the top is going to be negative 6, on the bottom is negative 1. So we're looking for two numbers that multiply to negative 6 and add to negative 1. That's going to be negative 3 and 2. So on the top is x. So we have x minus 3 times x plus 2 equals 0. And we're going to set each factor equal to 0. So x minus 3 equals 0 and x minus 2 equals 0. So we get x equals 3 and x equals negative 2. So this time we have two answers that we want to check. So let's first check x equals 3. That'll be 3 plus square root of 31 minus 9 times 3 equals 5. So that's 3 plus the square root of 31 minus 27 equals 5. So 3 plus the square root of 4 equals 5. Square root of 4 is 2. So we get 3 plus 2 equals 5, which is correct. Next, we want to plug in negative 2. So x equals negative 2. Negative 2 plus square root of 31 minus 9 times negative 2 equals 5. So we get negative 2 plus the square root of 31 plus 18 equals 5. Negative 2 plus the square root of 49 equals 5. And the square root of 49 is 7. So this is correct as well. So that means both answers work. So the answers are 3 and negative 2. In this next problem, there's no way to isolate the square roots, so I'm just going to set it so that each one is on one side. So I'm just going to add square root of 2x plus 3 to both sides. So we have 2 times rad x plus 1 equals 1 plus square root of 2x plus 3. We can get rid of the square root on the left by squaring both sides. So then we'll get 4 times x plus 1. So make sure you multiply the 2 on the outside by this, or square the 2 on the outside as well. And then for 1 plus rad 2x plus 3 squared, you can use perfect square trinomials. That'll be 1 plus 2 rad 2x plus 3 plus 2x plus 3. So now we have another radical, and this time we can't isolate it. So we want to combine what we can and move all the numbers to one side. So we have 4x plus 4 equals 2x plus 4 plus 2 square root of 2x plus 3. So here on the left I distributed and then I combined the 3 and the 1. So now I want to isolate the square root, so I'm going to subtract 2x and subtract 4 on both sides. So we get 2x equals square root of 2x plus 3. 2 times the square root of 2 rad 2x plus 3, sorry. And then we can divide both sides by 2. So we get x equals square root of 2x plus 3. And to get rid of the radical, we can square both sides. So we get x squared equals 2x plus 3. We want to move everything to one side. So we get x squared minus 2x minus 3 equals 0. And to factor, we can use the x method. So on the top would be negative 3, on the bottom is negative 2. So the two numbers that will multiply to negative 3 and add to negative 2 are negative 3 and 1, and we have x on top. So that means we have x minus 3 times x plus 1 equals 0, and we're going to set each factor equal to 0 and solve. So that means x equals 3 and x equals negative 1. So we have two numbers. We want to plug these into the original equation to check. So let's start with x equals 3. Okay, so x equals 3. So that'll be 2 square root of 3 plus 1 minus square root of 2 times 3 plus 3 equals 1. So that's 2 times square root of 4 minus square root of 6 plus 3 equals 1. So that's 2 times 2 minus square root of 9 equals 1. So 4 minus 3 equals 1, which is true. So that means x equals 3 is a solution. The next one we want to check is x equals negative 1. So we want to plug in negative 1 into the original equation. So that's 2 times negative 1 plus 1 minus 2 times negative 1 plus 3 equals 1. Okay, so we have 2 rad 0 minus negative 2 plus 3 equals 1. So that's 2 times 0 minus square root of 1 equals 1. So we get 0 minus 1 equals 1, which is not true. So that means only 3 is a solution. Okay, and then these last two are using the fractional exponents. So in order to get rid of the fractional exponents, we can use an exponent that's the reciprocal. So in this problem, since the exponent we're trying to get rid of is 2 over 3, we can use the exponent 3 over 2. Because when we multiply, let me just write this over here. 2 over 3 times 3 over 2, that's going to simplify to 1. So then the exponent gets canceled out. So for the 9, we're also going to use the exponent 3 over 2. So on the left, we're just left with x plus 2. And on the right, if you don't remember fractional exponents, the denominator is the root, so it's square root of 9. And then the numerator is the power, so it'll be cubed. So square root of 9 is 3, and then 3 cubed is 27. So this is, 27. Then to solve for x, we're going to subtract 2 on both sides. So x equals 25. And for this one, we want to check as well. So we have 25 plus 2 to the 2 over 3 power equals 9. 25 plus 2 is 27. And 27 to the 2/3 power means cube root of 27 and then squared. So the cube root of 27 is 3, and 3 squared is 9. So we get 9 equals 9, which is true. So that means 25 is the solution. And for this last one, our exponent is 3 over 2. So again, we want to use the reciprocal. So that'll be 2 over 3. So on the left-hand side, we're left with x squared minus x minus 22 equals 27 to the 2 over 3 means cube root of 27 squared. So that's 3 squared, which is 9. So we have 9 on this side. Then we want to subtract 9 on both sides. And we get x squared minus x minus 31 equals 0. We can try factoring first. That's always the method I want to try first. So that'll be -1 or -31 on the top and -1 on the bottom. But -31 is prime, so no numbers are going to work. So since factoring doesn't work, that means we have to use the quadratic equation. So a is going to equal 1, b is equal to -1, and c is equal to -31. So x is equal to -1 plus or minus the square root of -1 squared minus 4 times 1 times -31 over 2 times 1. So then we get x equals 1 plus or minus the square root of 1 plus 124 over 2. So x is equal to 1 plus or minus the square root of 125 over 2. 125 is divisible by 5. So 125 would simplify to 5 and 25. And 25 would split up into 5 and 5. So we have a pair of 5s and a 5 left on the inside. So that'll be 1 plus or minus 5 rad 5 over 2. Okay, and if you have to use the quadratic equation and your answer isn't just a number, then you do not have to check. So if your answer is an irrational number, you don't have to check.